All right, I think we're ready to get started. Welcome to our Next Gen CAM Best Practices Powermill webinar focusing on rib machining. Hopefully that will take a little bit of your time this afternoon so you can learn a little bit more in depth about rib machining. Before we get on our way here, let's just go ahead and we're going to have everybody muted during the webinar. After the webinar, towards the end, we'll have a Q&A section. During the webinar, if you have something that you'd like to focus on, feel free to enter those questions into the question inbox there, Q, and then we will get to them towards the end of the webinar. Before we get into the content itself, I'm just going to go ahead and cover a few things on some slides here. So we'll be doing these new best practice format webinars, which are going to be about 45 to 60 minutes of your time. This is a little bit different from what we used to do. We used to do about a 3 to 4 hour best practices, maybe 2 to 4 times a year, depending on the content and the timing. But those webinars were quite long, and we figured what we could do is break these up, do about a 45 to 60 minute live webinar every month. And really focus on single topics and get into more of a deep dive on those topics, kind of giving hopefully all of our customers a little bit more focus and training centered around these best practices. So basically, we'll be doing this across all of the Autodesk CAD/CAM platforms that we cover. So any of the CAM platforms for sure that you might have within your organization, look for these webinars. In the future, you should be getting information through email, or you can check out our website. Now, we do have a new website up. So if you are interested in checking this out, you can go to our website. You can go to our support, and we can find the calendar available on our support website here that can actually show you when best practices are going to be held. And you can go into our training as well and go into our best practices to get there from our new website. So feel free to check that out, along with the calendar and the ability to be able to navigate to get to the training you might need in the future. We also have video training and video content that we'll be releasing. So for each software, including our Powermill software, we'll be having these webinars up on the website, as well as some future training tips and tricks videos, things like that. All right, so this webinar, or sorry, one more slide here. So our team's growing, so are the services and the training that we're providing. So on the website, you can look for the more advanced training that we're going to be covering throughout the rest of the year here. But we're also growing our team. We've actually added a Powermill tech to the team here for the Powermill team, and then we've also added a sales team member in the West there, and then also a customer success to be able to help with all of our customers' needs as far as from organizing your training, setting things up, and then also follow through after the training to be sure that you're satisfied. All right, let's get into the rib machining focus. So this kind of course is going to cover rib machining, the overall process all the way through. We'll go through a simplified process showing the application as far as the tool path itself, then preparation for the tool path, what you're kind of generally going to want to look at. We'll get into some complex pattern definitions so that you can kind of see how the tool path works when things get a little more complex in the geometry. And then we'll look at some verification and some other case uses as well. With that, I'm going to go ahead and jump over to Powermill. Taking a look at our first example here, this part really kind of shows the type of geometry that rib machining is focused on. Within this toolpath, it's really designed to find features for the longer, deeper slot or channel type geometry that ribs within a mold are designed to. And if we look at the
older strategies we may have used to be able to machine these features, such as constant Z, it really starts to show some inadequacies with the toolpath itself. We have a whole lot of time spent linking toolpaths together, and on top of that time, these links are really inadequate on how they enter and exit the toolpath strategy itself. So with a toolpath that slices itself down these features, as long as those features are maybe lofted on surfaces on the top, or coming up to radiuses, or joining radiuses together, you're going to get discontinuity in toolpath strategies, and then also within the linking and lead-in moves across those toolpaths. And that causes diving within the tool, which essentially will end up causing breakage, and uncontrollable breakage at that, something that we can't predict very easily. Now, if we look at the rib machining strategy versus that toolpath, you'll see first off that there are a lot less linking moves involved in the rib machining strategy. The order, as well as the leading in of the toolpath itself, has a lot more control, but the bigger part of that in this toolpath is that it is going to follow the surfaces and machine down the walls, down the center of the surfaces, clearing out that geometry, and we can define that per our cutter and per our cutting conditions a lot easier than we can in any other toolpath strategy. Moving over to our main example for this best practices training here, let's go ahead and cover first and foremost some preparation items, maybe some startup file things that we could look at. One of the more important things you want to be sure to do when we're approaching rib machining, I think, is to get some tools squared away first and foremost. But typically how we might go about doing this is to make sure that you have a template set up, some sort of template or macro that brings in your standards for maybe the machine, or standard tools that you might have in the machine for the process, or just standard tools that your organization uses for the rib machining process. So just to demonstrate this, I have a quick button up here within some of my customization tab in Powermill that I'll just click on this, and that'll import some of my typical tools that I might use for standard ribs for my processes. And these can vary, and this can be vary in complexity, but for this demonstration I just have a few tools already pre-selected. Now once I have those tools loaded into my Powermill project, I'll go ahead and take a look at whether or not the tool selection is going to be appropriate for the machining that I'll be doing to these ribs. So I'll activate a tool that I believe will do some of the processes. Usually I'll start with a rigid tool. So I'll go ahead and just activate this here. And one of the things we can do to kind of interrogate these features is we can, of course, go to our Home tab and come into our Measure function and use our Measure function to measure any of these features. However, something that I like to do with a little more visual check to these features is I like to come up to my View tab. And in my View tab, what I'll do is I'll use the Dynamic Sectioning option. And I'll set this dynamic sectioning to a known plane. So in this case, we'll go into the x-axis. And then from the x-axis, I'll go ahead and drag the sectioning over. And with the sectioning dragged over, we'll go into a front right view here, and fit screen to take a look at this. Then what I'll do is I'll Control T to turn on the drawing from my tool. So that's the cursor option, drawing from my tool. Then I can come in and I can actually take a look at these ribs and see whether or not my tool is both going to fit within the width of this feature as well as reach the depth of the feature. And then I can kind of continue the sectioning on through to see if the tool will fit for the majority of the work. After I've got the tool selected, there's a few things that I may want to do to assist with machining on the part overall before we even get into the rib function. One of those things, if we go ahead and turn on one of our finishing operations here, is to be able to cap these rib surfaces just for our general finishing of the core feature that we're looking at here. So if we look at this toolpath, and this is just an optimized constant Z toolpath with our chosen finishing ball end mill here that we did some preparation work on in the file. But if we look at it, you can see that it's diving down within the rib features. When you bring in your work within the rib machining process, you'll want to take a look at these rib features and cap these surfaces. Well, the utility that we use to be able to cap these surfaces is actually not inside of Powermill. There's a utility within the Powermill modeler. So my process to do this is to typically take the entire model, and I'll just copy the entire model. And then I like to have the Powermill modeler opened up beforehand. Now again, Powermill modeler, this is a feature that's within Powermill Premium and Powermill Ultimate. That's the same for the rib function itself. If you're doing rib machining and utilizing this toolpath, then you're using it within the Premium or Ultimate product line here within Powermill. Once you're inside a power shape, you just simply paste your model. So you could just paste that model in there. So it's not necessary to use the Powermill importer. If I right click on the model surfaces themselves and export them or do surface modeling or something like that, we don't actually have to come in and click on surface modeling to launch it. Sometimes that seems to take a little bit more time, in my opinion, than having Power Shape or Powermill modeler already open. Within the Powermill modeler, we can do a few things. Let's first go ahead and take a look at our tool set that we want to use. So inside of surfacing, off into the manufacturing panel here, you'll see that we have the rib capping option. I'll go ahead and launch the tool. There's a couple of ways that this can help cap surfaces like this really quickly. One of them is to select the top faces. So if I just come in and select some of these faces, shift selecting, or however you want to select some of these surfaces, we'll use that top surface to do it. We can preview this before applying or dedicating to the cap function. You see what that does? That caps the surfaces automatically. I'm going to change the color here so we can re-preview that. Let's change that to yellow and just take a look at that. Now I'm going to cancel out of this. Now you notice that my model has some colors already changed or altered in the model. Now this can be done either on the design level, or we can go through and select this and change the colors ourselves. It is not vitally important to do this. However, it's best practice to be able to have those features colored for selection. Makes selection out at the shop floor or out at the programming level a lot easier. So I'm going to go to the Home tab, and I'm just going to select all of the rib features here. So by using my filter color option. Within the filter color option, I'll just invert my color selection for the filter, and then I'll just select all surfaces. With all of our surfaces selected now, let's go ahead and go to the Surfaces tab. Go into our rib capping tool. With our rib faces selected, let's go ahead and change our rib width. In this case, it's set to 200 thousandths. That should be adequate, but you can take a guess at the width of your rib, or you can measure it. With the tangent continuity, 90% of the time automatic is going to work great for you, but there are a couple of other options that we can choose from how that's going to find those tangent edges to the surfaces themselves. I've got my color set to yellow once again. Let's go ahead and preview this just so we can take a look at those before applying it to the model itself. With those surfaces capped, and we can see that if this is my my desired outcome, then what I would next do is go ahead and apply that, and I'll close out the rib capping tool. Let's go ahead and again, let's change our filter selection. Let's go to our yellow. I'll invert that. Select all surfaces. Now instead of taking the entire model back into Powermill, the model already exists inside of Powermill. All I need to do now is copy this. So I'll go ahead and copy all the selected surfaces, jump back over into my Powermill session, and then over in models, I'll right click on it and I'm going to paste as a new model. So what this does is that brings those capped surfaces in on a separate model level. Helps with selection, so I can easily come in and I can select all of those surfaces, and then I can come in and on one of my levels, create a new level, activate it, and acquire that geometry so that I can turn it on and off, or turn the visibility on and off as I need to within the level. Also make a selection using the level if I need to. With that, once I'm at the point that I need to start machining those ribs, it's important to come back and make sure that you go into your thicknesses setting. So our little preparation sets here, within the part, we did set up an ignore level to be able to ignore the part in the build here. If I take a look at that level, you'll see there's a part actually on that level with our thickness shading here. Set, you'll see the red part there. That's set to ignore. I do like to set my sets on another of rib surfaces on another level. So I'll go ahead and come down to level 7. That's my yellow level and the same color as my color of my rib cap features themselves. So I'll go ahead and set this. I'm going to set this to ignore. And then we're going to take the selected features. So I'll go ahead and go to that level, select all, and drop that down into those features so that all those surfaces are set to ignore when I start my toolpath. Now you can, of course, you can set this within the toolpath itself once we get into our rib machining to take a look at that. Now that the thicknesses is set, once we create our new toolpath, that will automatically apply the ignore option that's in the thicknesses. But for the existing toolpath, we can simply just go in to the toolpath and change a setting to recalculate the toolpath. Once we recycle that toolpath, maybe I'll just come in and change a thickness option. We'll set that to 10 thousandths. And we'll go ahead and cue that in the background for background calculation. With those caps in there, we will see all of those dives will be resolved for our finishing strategy. Once that's fixed there, we can actually move into our ribs option. So I'm going to go ahead and turn the level off for the ribs themselves. Let's go into a top view, and with our tool that we're going to be using for the ribs activated, let's go ahead and take a look at what the rib machining toolpath option can do for us. Now, rib machining can be found within the strategy selector here in its own option here in the strategy selector within ribs. If we look at rib machining, it's right there. We can go ahead and double click on that to fire the rib machining off. You'll also notice that I had that rib machining automatically set up in my create toolpaths shortcut. So I had that set as a favorite. You'll notice that favorite selection is there. So once the rib machining toolpath starts, it starts with our rib options. We can see that we have our definition for the geometry, and the way that the rib machining works is that it will take a pattern to scan along the pattern geometry, and then along the surfaces sets that we will create, it's going to scan those surfaces and apply the appropriate toolpath strategy in the style that we select. So I'm going to go ahead and leave the style default set to center here. I'm going to apply a clearance. Now this is an important feature in the toolpath, as this gives it that little extra distance to cut into the surface feature, so just starting above the surface. Usually I'll go by an appropriate amount, that's my step down, just so I can lead into the cut a little bit on the first cuts that it'll make at the top of the rib features. And then I'm going to go ahead and set this to an offset up option. So the offset up option, creating slices from the bottom up of the bottom of the surfaces that will be selected. I'm going to leave my tolerances to 5/10 here, and I'll set my cut directions to any, so we'll do like a back and forth method on this machining strategy. So let's take a look at the more important side of this, which is the pattern creation. Now we've got our typical pattern creation where we'll create a new pattern for us here on the left. Then it also has the ability to access the pattern editor, but on the right hand side of all the options for the pattern, you'll see that there's this grid looking pattern edit option here. This is actually a specific toolpath to rib machining. This is our rib pattern editor. Now it's set up within a workflow to extract necessary patterns for the rib machining. Now you see here our tool sets are kind of truncated down from our regular curve editor. We have the create section, which is now only limited to lines. Our edit section, which is going to be more for editing single individual lines. Our instrumentation is automatically drawn for us. And then from here we have a different finish option that we'll be using to create the toolpath. Now I'm going to focus this portion of the demonstration just on this center region here, and we're going to create just a simple rib with some single line options. So I'll create a single line option, and I'm just going to drag close to the center of my surface. This doesn't have to be perfect, and that's one of the nice things about this rib extraction tool, is that the sketch doesn't need to be tied to the center points of, or to the midpoints of any geometry to drive the toolpath itself. You'll see that my pattern is just a little bit crooked there, just a little bit off center. Again, that's not necessary. What this is going to do is use this pattern just to guide a scan of the surfaces we select. Now the instrumentation turned on, I do like to make sure that I'm going in the proper direction that I want to machine. That's just my best practice as I approach machining ribs in general. From the pattern creation, once we're finished here, we can then start the rib surface editor. Now this tool is kind of an automated tool that allows the selection of the ribs, and that first option within the surface selection here is automatically select. So once I click that, what that does is that selects all of the surfaces that scan from the projection onto the model. And you'll see that all of the surfaces within that region are selected appropriately. Once those are selected with that automatic option, I'm just going to hit the accept button. I'm going to rename this quite quick as rib 1. With that example set, let's just go ahead and check a couple of things. So force of habit, make sure there are no limits set. And then also within the thicknesses, make sure that that ignore is selected so that it sees past the cap surfaces. With that checked, let's change our step down. Let's give it a little more appropriate step down. I'm going to use 50 thousandths just for the calculation of the example here. And let's just calculate this. With the toolpath calculated, let's take a look at the strategy that the toolpath that calculated. If we look at this here, you can see that the ribs themselves, it's going down a center style cut. That means that it found the geometry with the scan of the pattern and created a single toolpath down the middle of our rib. And what you'll notice is that even though the pattern wasn't even and there were some surfaces selected around the boss, the toolpath was intelligent enough to calculate itself down the center of the steep walled geometry. You also see that my leads and links cut themselves off, so we have our back and forth pattern machining down the center of the rib. So the pattern itself, not too terribly important. What you would want to avoid is multiple patterns intersecting each other. We're going to see that in a moment as we create a couple of more patterns and a couple more toolpaths here. Let's go ahead and clone our rib operation here. And let's take a look at a couple of the other options. So we had our center option, driving a rough, nice roughing toolpath down the middle of our rib. Maybe we want to come back and we want to finish our walls. So let's go ahead and take a look at what walls does. And let's go ahead and calculate our wall toolpath. And you'll see that this toolpath uses the wall to guide the tangency of the cutter down, similar to a kind of a constant Z strategy. Now we are set to the offset up option, so I'm going to go ahead and recycle this toolpath. Let's go ahead and change a couple of parameters here. Let's go ahead and take a look at our different offset strategies. Now offset up, creating of course even slices up at our 50 thousandths. We left a thickness of 10 thousandths. I'll go ahead and zero that thickness out there. And let's go ahead and change that to a merge option. Now you'll notice that down here from my step over to the right hand side of the step, there's my order that's selected by my pattern. Now while we were creating the pattern, I showed the orientation of the pattern using the instrumentation there. This is what's driving how the toolpath's trying to calculate its order. It's trying to drive itself along the direction of our pattern. There's another option here, and that's the actual shortest path that could navigate itself in a similar fashion, since each segment of our surfaces is along that path anyway. But I'm going to leave that for now. Let's go ahead and change this to our merge option. Let's calculate that toolpath, which essentially takes the depths of the toolpaths but follows the contoured region of the surface, meaning follows the surfaces as it transitions. And we can kind of see this within this radius as the toolpath transitions up along that surface, merging the cuts together. I'm going to recycle that one more time. Let's take a look at another option here, which is our favorite option. That's our constant Z toolpath. Now this uses the similar slicing technology within the constant Z. It's going to give us a nice clean toolpath. So I'll calculate that. And you'll see that the constant Z option gives us our individual slices working down in a nice constant Z fashion. If I were to go ahead and recycle this toolpath once again, I'm going to go ahead and change the max step down for this. Let's go ahead and give this something a little bit smaller so that it looks more like a finishing toolpath. And let's also change the type of style to our last style. We're going to go with the center and walls. This is my favorite to get in and really clean up and finish a strategy for ribs. Oftentimes with the complexity of ribs, and you have multiple ribs, what most users end up doing is they'll select this strategy and they'll use this with constant Z, and they'll create a toolpath that does the majority of their ribs for them. And they'll do it in a lights out fashion. You'll run this toolpath with a small step down that will have successful lead in, lead outs, where the tool won't actually typically break, and you'll run this overnight and let this run small cuts. And with good coolant and good chip evacuation, the toolpath will be efficient enough to clean out your ribs overnight on a lights out fashion. I'm going to queue this toolpath since it will take a little bit more time to calculate. While that's calculating, let's take a look at the finishing strategy that calculated. So the finishing strategy recalculation did not actually have the thicknesses applied. So with that, we get rid of some of the deep dives that we were having along our rib features due to the capped portion. I'm going to turn that toolpath off, turn off its visibility. So while that first top portion is calculating, let's take a look at the top view here. Okay, from our top view, let's go ahead and apply yet another toolpath, another rib machining toolpath. I'm going to go ahead and start this rib toolpath over. Let's take a look at the longer portions of our rib strategy here and how things are going to get selected within the strategy itself. So we have a couple of things going on. One, I want to machine the length of this portion and kind of cross the gap of our square features here on the outside, crossing over to our boss features as well, and then also we'll be transitioning up this radial portion right here. To do this, let's go ahead and reset a couple of items here. First, let's go ahead and check and use a different tool for this strategy. I'm going to switch it up. We're going to go with a tool with a little more length to it to be able to handle this. I'm going to switch to the 1/8 inch tool, just kind of a medium 1/8 inch tool with the larger tool radius on it. 30 thousandths. I know that it's going to reach down a little bit further down into the rib portion. Let's go ahead and take a look at automatic verification with this as well. Now, with my toolpath typically calculated the way I like it, I'll do this with automatic collision avoidance turned on. I'm going to tick that off because I'd like to show how we can verify and then also split off the toolpath using the verification. So I'll untick that, and let's go ahead and create a new pattern as well as a new set. I'll go into the pattern editor, and again from our top view that snaps us to it directly. Let's go into our line. Again, you don't have to be perfect with this. Let's just click out close to where we want it to be in the center of the surfaces for our toolpath. Click that, and I'll go to next in the rib surface editor. So click on that arrow to go back into that. You can see there, this also will return you to the pattern if you need to go back to the pattern to make an adjustment. Maybe you made a mistake. I'm going to do the automatic selection again. Now, the automatic selection this time, as it crossed over some of that scan region for the surfaces and extracted our surfaces, you'll see that it also scanned some of this square region here on the bottom of the square surfaces, as well as the top of the surface here. We don't want that, so what we can do is while we're in here, anything we do to the surface selection applies itself to that set. Let's go ahead and hold Control, and I'll just Windows select all those surfaces and Control deselect basically. Let's go to the top view on the other side and do the same thing. Control select just corner to corner to get rid of all those surfaces. I'm just going to double check that I didn't miss anything. And it's hard to tell with the colors, but I do have highlighted areas there. I'm going to hit accept to this. That adds those to the set. If I go into my levels here, I'll turn off the part. We could take a look at the set. We can see that we've actually missed a couple of features on that selection. Just down the radius portion right there. Let's go ahead and be sure that those are selected. We could do that, again, from our geometry selection area in the rib machining. Just over on the right-hand side of our surface set selection, there is, again, the ability to get into the sets editor to be able to select the surfaces manually. So I can come in and then just grab and shift select those. Looks like they're in the set, however, I just want to make sure, so I'll accept that. And then let's go ahead and calculate this toolpath as is. I'm going to go ahead and check limits again just to be sure, and then we'll calculate that. Let's go ahead and turn on our main core insert level once again. Now let's take a look at our toolpath and how it calculated to the intersection points here, as well as how it calculated itself along the steeper regions of this core insert here. So if I look at that, you can see again as we come to our intersections, the toolpath is smart enough to cut itself off to the wall selections. So if I come in here and I come into like an area where it's going to make a transition and I simulate at that point, let's go ahead and change our tool shading. We can see that the cutter diameter here at its extent is coming practically out to center just off of the tool, and just as it exits that flat portion where the pattern has scanned that geometry for the surfaces, it's smart enough to cut itself off at that point. So same goes for our intersection here. If we look at this intersection, you'll also see that it gave itself a little bit of room. It knows that it can lead in and out safely because of gouge protection off of that surface. Now these lead in and lead outs do need to be altered a little bit. With that being said, let's go ahead and close this out. Let's do that. Let's take a look at our lead in and lead out. For the majority of the lead ins and lead out, it's pretty safe to go into the surface normal arc and apply a small surface normal arc to get to the majority of your surfaces. I also like to come in and force a vertical arc in case that does fail. I'm just slightly smaller, depending on my geometry, of course, and what I'm trying to do. Once I apply that, we'll have any alterations to that to be able to clean things up a little bit. You could, of course, come in and change your first lead in and lead out to be a ramp if you'd like to. I, however, like to come in and select them individually. It takes a little bit more time. However, when I do this, this allows me to come in and force the ramp just where I need it, exactly how I want it. And this is going to be, say, 4 degrees on entry at 50 thousandths. I'll accept that and I'll do a local apply to that so that I come in and I have a ramp lead in just on the first lead in, and then I just snipe out each one of those first lead ins on the cuts, kind of giving me a little bit of an advantage to not break my tool and ramp in on those specific regions. And I'll go through, and I'm not going to go ahead and do this, I'll just accept this for now, but just kind of demonstrating how I like to go through and force that ramp entry, and then I kind of know I'm not going to break my tool within specified parameters. Let's go ahead and take a look at toolpath verification now. I'm going to right click here and just go into my verification for my toolpath. If we take a look at verification, I'm going to make sure all my options are ticked off for this. With the holder clearance, it's adequate. In this case, 50 thousandths from the holder. We'll do 5 thousandths from the shank itself. Let's go ahead and apply that. It'll tell me where the collisions are found. Now, I have collision sections set on my toolpath in my drawing options. So colliding sections is ticked on. That's going to be able to show me where my colliding sections are. Now, we can, of course, replace the tool and maybe go with a longer tool, something with a longer flute, with a longer shank relief hanging out of the holder. Oftentimes, we want to stay quite rigid and short and stubby to this as much as possible. That being the case, oftentimes we want to do something that's a multi-axis toolpath. Now, we can do 3+2. However, inside of the ribs toolpath, if you're looking to go full multi-axis, there is not an option. Or if you're looking to use like a lead lean to set the tilt angle or anything like that, or set limits, there isn't the option to be able to do that. If you look inside of the toolpath, you'll notice in the options that there isn't a tool axis control option. So what we do need to do is we need to go and do the 3+2 method with this. So I'll just go ahead and first and foremost, let's close this out and go back to toolpath edit. So we're going to split the tool off. Now you can use the split function to split and get the most out of this toolpath. However, I don't recommend doing that, as you'll get different start and stop points within the cut where it decides to split this off in verification. That can lead to tool breakage sometimes depending on the geometry. So we're going to go ahead and limit this toolpath from a point, just blending in on the toolpath here. That'll work right there at that toolpath marker there. Let's go ahead and take a look at this and do this right on the side view. And I'll keep everything that's on the outside up. And we're going to go ahead and keep the original just in case I make a mistake, and we'll apply the toolpath. Let's go ahead and cancel that. Now, there's some leads and links that are still colliding, I think, up in the center here. Yeah, you see some red here. So we've got some leads and links we're going to have to take care of after the fact. But for right now, let's focus on our area that we have set to tilt to. Now, I do have a work plane created here in the file that was already set to that surface. I'm going to go ahead and delete that work plane. Let's go into our toolpath real quick because we're going to make a copy of it. Let's duplicate the toolpath. All right, so the duplication of the toolpath is set. Now we're going to leave the drawing on the old toolpath. We're going to use that as our guide to blend the two toolpaths together. Let's go ahead and go to the left view, and I'll turn off the model and turn on the wireframe so I can see the end of my ribs there. So we'll create a work plane aligned to geometry, and I'll have to turn the surface back on for this, but let's go ahead and just grab that at the vector that we want to machine this at. And let's double click on that to get into edit the work plane to swap the axis to align our machine appropriately. We'll accept that. Let's do our toolpath connections so that we can get a nice safety plane. I'm going to select that surface right there once again, go to my safe area, set it to plane, calculate that based on model only, and then apply that safe area and accept it. Now from here, we're just going to go back and use the pattern only. The surfaces will remain the same. Let's go into our pattern option, and from a top view now from this work plane, we can create our pattern in our pattern editor. Create some lines. In this case, I'm going to go climb cut all the way through this, basically. I want to maintain the cut into the blend, basically, from that point, and then all the way up to a blend of the toolpath, basically where it tapers in. I might allow it for a little bit more. It's totally up to you how detailed you want to be with this. Again, lights out machining, you gain some time there. Some pluses to that, but let's go ahead and just blend these in with the pattern, and you'll see that the surfaces didn't change selection, and the pattern is really what's going to drive where the toolpath starts and stops at. So with the new pattern defined, everything looks good work plane wise. Let's go ahead and calculate that. And now we can see that we've 3+2 machined that region, and we missed the blend just a little bit, so we might have to go back and extend that pattern. Well, that's okay. We can recycle the toolpath, and we can come into our pattern editor for that, not our collect. And we can come into the pattern options and edit the pattern. And let's just go ahead and drag that point up just a little bit. Again, getting it past that tapered region sometimes takes a couple of times to really get in there. Let's drag that in point up. There we go. So it's easy to come in and edit these features and then recalculate the toolpath. So 3+2 and then blending into the existing cuts. Fairly easy to do if you need to do that. Let's go ahead and turn the shading back on and the wireframe off. And I'll go ahead and close this out. Let's go ahead and go to our standard work plane again. We're going to go back to that. And let's activate the other rib machining toolpath. The calculated rib machining toolpath on the top resolved, and then we could just look at the details on that for the center and the wall cut option there. You can see how that's machined that center out nicely. We might need to again change some leads and links on there to resolve some of the blood that's on our verification. But let's do this. Let's do the top area, and let's finally get to this square shape. All right. So we've done kind of things separately here. I've done the center portion with the bosses. I've come in the lengthly portions. I've also come in and tilted the machine and done the radius. Let's go ahead and go to a top view here, and let's focus on our square features here. So with the square features, works exactly the same way. The difference is that we aren't going to try to project, say, the edges of the part and maybe even offset the edges of the part at that point. There's no point in doing that. Again, the pattern within the rib machining strategy does all the work for us. So I'll go to the Home tab and relaunch another strategy. I am going to select a smaller tool. Let's make sure we have like a smaller tool capable of getting down into that region. It is a little bit narrow, or more narrow in that area. So I'll keep it with the 062. In mill should work fine for this. Let's go ahead and start our rib machining toolpath. And again, I'm going to create a new pattern. All right, we're going to create a new set, of course, to match the pattern in this case, so that we can extract just the square geometry that we're trying to get to here. So let's go ahead and create the pattern. Now I'm going to use the polyline option, or the continuous line option, if you will. I'll zoom in on the area. Now, I like to start this more in the center. You don't really want to start on edges or corners. It makes it just a little bit harder for the definition of what we're going to do. We're not actually going to create a perfect radius and fillet or anything like that, but we do want to stay kind of close to the center. If you deviate across the top surface, it may fail on one of those radiuses. Now, occasionally you will get lucky, but it's best practice to go ahead and kind of keep your sketch a little bit center of your part. Now in this case, I'll just grab the polyline around like that, give it a couple clicks, maybe 3, kind of stay in center. And then I'll come in, and I don't need to make contact here. I can click on that end point there, and then within the pattern option, there's a flyout for the polyline that actually allows me to connect and end the connection there. So let's go ahead and accept that. And then we'll go into our surfaces. Let's automatically select that. You'll see that it grabbed the walls as well as the floor just around that active pattern. Now we can change our style to whatever we want to machine to and calculate the toolpath. Let's go ahead and close the toolpath strategy out, and let's turn off some of these other toolpaths and just focus on our center toolpath here. All right, so we've got our leads in, lead out, kind of sweeping in at that point, but you'll see that we have it set to center and just cutting down the center of our feature there. We of course could do center around wall and finish the whole thing in one shot, but the object here is to take a look at how that pattern still drives the toolpath, and the toolpath is still going to follow the surfaces and center itself to the surfaces. All right, then we would just duplicate that process on the other side. Now, I've separated everything out up to this point because of cutter diameter differences and length differences. Of course, that makes a lot more sense to do that. But let's go ahead and take a look at another way we can do this. I'll leave the tool active, and we're going to use the same small tool since it will enter all those features. Let's take a look at what happens when we want to do the entire project. So I'll go ahead and start another rib toolpath. Create a new pattern and a new set. Let's go ahead and come into our pattern. I'm going to do a single line for this. Let's go ahead and do our first set here. And we'll do our across. Kind of zigzagging the pattern direction because I'm going to drive the pattern once again for this. Now let's create a separate pattern for the center. We want to polyline that. There we go. Again, like center of the arcs works out pretty decent most of the time. All right, let's see if I can close that up. Let's create the last rectangle. Why not? Or square. You can see it's not exactly centered. Like I said, that's the cool thing about this utility, how it extracts the surfaces. Well, let's get another point in there just in case. Let's go to the rib selector for the surfaces here. Now, instead of using the automatic selector and projecting all of that madness there, having these colors set allows us to come in and use our smart selector to be able to come in and grab that color and select all those surfaces. Once they're selected, I'll hit accept. They're now inside of that surfaces set. And from here, I can calculate the toolpath. Okay, so that calculation time takes a little bit longer as the calculation has to find itself around each of the intersection points of the surfaces, but it does calculate within about 10 or 15 minutes, about 10 minutes, depending on the complexity and the number of rib features that you have. But combining together those features all in one pattern does get the job done. Now, you'll note that we did not do the boss features that are in the center of the part here. Now, with boss insert features or round components like that, having to go in and sketch around those features to extract that geometry actually doesn't make a lot of sense. So my experience, at least with the round portion of the geometry, it is better to actually create a separate toolpath for that. In this case, we'll be looking at this optimized constant Z that we created just for the center of it. So we've got our optimized constant Z toolpath calculated the way we want it now. I'll close it out. There's no 3-axis issues with it. I can take the rib machining toolpath that I want and I can hold down control and I can append the two together. Yes, I want to append the two. Now all we have to do is change our order. So right now it's skipping over each one of the boss features in there. So let's go into toolpath edit. Let's go into reorder. And we'll just do an automatic reorder at first. Automatic reorder resolves. It's going to go the shortest path from the center out. So appending the toolpaths is no problem as long as they aren't multi-axis toolpaths and as long as they use the same cutter. With that, we've reached our time for our webinar this afternoon. So let's go ahead and go back to our slides real fast. Again, Powermill's rib machining option is found within the Powermill Premium and the Powermill Ultimate. If you have any questions about upgrading to be able to use this functionality or questions about the functionality in general, feel free to reach out to us. With that, let's go ahead and go into our Q&A. Before we start questions here, let's go ahead and just touch again. Future best practice options we're looking at. We are into ideas. If you guys want or have any ideas or have anything you think that would make a best practice to cover as far as features within Powermill, since there are so many of them, feel free to send in any best practices to support@nextgencam.com, or you could give us a call at 888-310-2674. Just mention the best practice and say, I'd like to see a future best practice on a particular topic. We have a couple of topics lined up that we're toying around with for our next webinar. Maybe stock model best practices. That's an often question that comes up, is how to leverage stock models best, because oftentimes it takes a lot of calculation. Maybe we go into setups and how to utilize setups versus the Powermill block options and just creating NC programs from the block options itself. Vortex best practices, maybe go into feeds and speeds for tool libraries, since there are different ways of doing those things too. We can get in depth as well for macros if you're looking into that. Either way, please feel free to reach out. And again, thanks for joining us for the webinar. Let's open it up for some questions.